Okay, so we're almost to the point where we're going to write our own recursive functions, but first we have to talk about one important thing, which is what happens behind the scenes when functions are called in JavaScript. If a recursive function is calling itself over and over and over again, what happens behind the scenes? And this is important for us to understand in order to write effective recursive code that doesn't break. So in almost all programming languages, there's some data structure behind the scenes that's managing function calls. When functions, when they're invoked, often are waiting on other functions to return. There's a special order that happens, right? Functions don't just happen randomly. Like if you have a function called first, and then inside of that function it calls a second function, you need them to go in the correct order. And so there's a data structure in charge of that in JavaScript called the call stack. So you can think of it as a stack of papers or something. It's actually a data structure called a stack that we'll learn about later. You might have heard of stacks and queues before, but all that we're going to say for now is that when a function is invoked, it's placed on the top of the call stack. So just like if we have a stack of papers on our desk, the newest one that we put on goes on top. And then when JavaScript sees the return keyword, or when a function ends, there's no more code to run, the compiler will remove the top item from the stack. So the idea of a stack, the reason I'm saying a stack of papers on a desk is that you put something on top. When you remove something, you also remove from the top. You don't remove from the bottom of a stack of papers. You take whatever's on top. So that's the idea of the call stack. What I'm going to show you now is what it looks like in the Chrome DevTools when we have a couple of function calls, what the stack actually looks like, how it reflects those functions. Okay, so I have a snippet here that I've made. It's very silly, but it has 4 different functions. There's a function called wake up, and wake up calls take shower, eat breakfast, and then it prints at the very end when everything's done, okay, ready to go to work. So wake up is invoked down here, and then wake up calls take shower, and take shower is simple, it just returns showering. Then we have eat breakfast, and eat breakfast is called, and it's a little more complicated because it sets a variable meal equal to cook food, which is another function. So cook food is going to then be called, and that returns, well, there's a list of items and it picks one at random. So it's going to pick one of these 3 things, that's what this code does, and just return it. So cook food might return eggs. Then eat breakfast was waiting on that. So meal is now eggs, it returns eating eggs. And then wake up was waiting on that, and because of eat breakfast, that was holding things up. Then we move on finally to console.log. Okay, ready to go to work. So I'm going to step through this one at a time, one function call at a time. And the way I'm going to do that, over here I have this call stack window open, and I'm going to add a breakpoint here. So as I hit this little button to run it, or Command Enter on a Mac, what's going to happen is that over here we'll see things added to the call stack. So I just hit Command Enter, and I'm going to step through it with this little thing here, this arrow. So first thing that happens is that we get to wake up, and you can see wake up is on the call stack now. It's the first piece of paper put down. But wake up isn't resolved. It hasn't returned something. It's not done. In fact, the very first thing it does is call take shower. So take shower is added onto the call stack. So now we have this stack with 2 function calls on it. So take shower is simple. It just returns showering, and you'll actually see that right here. So we're on take shower now. Return value is showering, and then it's removed from the call stack because it returned a value. Then we move on back to wake up. The next part of wake up, we already did this. Now it's on to eat breakfast. So eat breakfast is added to the top of the stack, and you can see eat breakfast isn't as simple. Eat breakfast is going to call cook food, and cook food is added to the top of the stack. So now we have wake up, which is still waiting for eat breakfast. Eat breakfast is waiting on cook food. So cook food is first, it makes this array of items. You can see that in the local scope, items is created now. Next line is going to pick a random item and return it, which is what happens. We returned protein shake. So now cook food is done because it returned, and we return back to, or I shouldn't say return, we go back to eat breakfast, which was waiting on cook food. So now you can see in eat breakfast, meal in the local scope is equal to protein shake. So we're going to return eating meal. And we return eating protein shake. So it returns, which means that eat breakfast next is removed from the stack. It's done. And finally, we go back to wake up, which has been waiting patiently this whole time. And we are able to console.log, okay, ready to go to work, which you'll see appear down here. Okay, ready to go to work. And now we're done with wake up. And we've finished now. We're at the end. There we go. So there's a lot going on there. But the idea behind it is that as functions are invoked, they're added to the top of the stack, and then they are popped off one at a time from the top as well. So the reason that we're going over this, first, hopefully that was clear, what's happening there. These dev tools are useful. If you've never seen the call stack tool over here, it's very nice to be able to step through and understand the order things are happening in and what's waiting on what. But the reason I'm showing it to you now when we're discussing recursion is that when we're writing recursive functions, we're going to be working with the call stack a lot. So you're probably used to functions being pushed on the call stack and popped off right when they're done. But with recursive functions, it's different. They keep pushing new functions over and over and over onto the call stack. In fact, the same function over and over and over, and it's waiting to be called. So if we take this idea of json.parse, calling json.parse, and it keeps calling itself over and over and over, the call stack is going to look like json.parse, 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 but it has to end somewhere. And that's what we're going to talk about in the next video when we actually write our first bit of recursive code, is where it ends. We've established that a recursive function calls itself, but how do we know when it stops? Because otherwise, isn't the call stack just going to continue to go forever? And we'll talk about that as well. So hopefully this made it a little bit clearer what the call stack is. It's this thing behind the scenes in JavaScript that it's a stack data structure, which all that means is that things are added to the top and removed first from the top. And functions, when they're invoked, are added to this structure. So next up, we're finally going to write some recursive code.